So, hi, my name is Dmitry Volk. I work for VMware now, and I help sometimes Chris organize this wonderful meetup. I also helped him build the original Cloud Foundry that he remembers nothing about now.
I remember that one. It just doesn't exist anymore.
Right. So I wanted I prepared a little demo for you, actual practical introduction to Mesos and some of the frameworks that use Mesos. If you've used it a lot, you probably won't get anything interesting out of it. But when I was trying to figure out what it was, I wish I saw a demo like that, so I hope you would be interested. First, I wanted to start with the question why PaaS systems, the classic traditional PaaS system as they're called now, they didn't really win big as we hoped. One of the things is that they tried to do way too many things at once. So they tried to take care of containerization. Yes, I said it. So basically taking your binaries that you've built and making them executable. They tried to provision like databases for you and message queues and all those common infrastructure pieces. They tried to coordinate between different pieces of your application if it was more than just one module. They provisioned virtual resources for you. They tried to schedule and execute, well, they had to schedule and execute your workloads. And of course, they would attempt monitoring and management of the application. So that became a little too restrictive. For example, the original Cloud Foundry that we just mentioned, it was a Java PaaS. So pretty much all of these areas were dependent on the fact that we were running Java, and not just any Java application, but Java web applications. So a lot of those things depended on that. For different systems like Heroku, for example, they tried to do something, I think it was called run packs, build packs, right? So where they would package the knowledge about how to build and how to run certain types of technologies into this build pack and use that. But then again, the number of technologies that you could use was limited. It has to be supported by the PaaS system. So now the industry seems to have taken a step back. Different companies, different teams are trying to tackle each of these problems differently and then combine them into various solutions. So that first thing was taken care of by surprise containers. So you really don't care anymore what technology you use. You build this runnable thing that carries all its data, all its configuration inside it. You can just execute that. Also, the common infrastructure like databases, message queues, and all other pieces of software like that, also containers take care of most of them as well. There are different products trying to tackle different things, but the scheduling and execution, one interesting solution is Mesos, which I really wanted to talk to you about. So there is another big word I could never really pronounce, commoditization of computing. Basically, you've seen this trend from specialized computers to big mainframes to commodity hardware. Now, things like Mesos, they really show you your computing resources as one big pool of resources. You really don't care where exactly on which hardware things are running. When I was trying this demo the first time, I had my laptop, a VM inside ECX container under my desk, and some guy's laptop as members of the cluster, and my programs were executing on either of those. So it doesn't matter where you run it, it's just one big pool of resources, CPU resources, ports, disk, memory. So Apache Mesos it is a framework designed first at Berkeley. They really like this data center OS metaphor. So if you look at your data center as one computer with the operating system, Mesos is the kernel. It's something that can execute tasks, execute processes. So it covers your whole data center and just executes stuff and turns your data center into a pool of resources. The architecture, I don't know if you could really see that. There is a diagram stolen from a site. So you have Zookeeper. These days, you can't really go without using Zookeeper anywhere. You have a Zookeeper cluster. And you have a number of Mesos master processes that communicate through that Zookeeper. You can have, they will elect one master, one standby master. Again, it's all transparent to you. You don't really care. So you have a few master processes, and on each of the machines that actually execute stuff, you have to have a Mesos slave running. So slaves run your tasks. Master communicates between the slaves and the frameworks. So by itself, Mesos can't really do much. It's the Unix style: do one thing and do it well. So slaves, the only things that they do, they offer their resources to the master. Again, they never speak directly, only through Zookeeper. They offer their resources to the master processes. When they're handed tasks to execute, they execute them, and they report on the task status. Masters, they forward the offers to the frameworks, to the consumers. And then when the frameworks assign tasks, they forward them to the slaves and route messages. Really nothing more. I don't know what you can do with just plain Mesos installed. I don't even know if you can actually launch something on it. At least I never tried. I know there is a CLI, but it's mostly for viewing the logs and figuring out what went wrong. So Mesos by itself doesn't create tasks. It doesn't assign tasks to the slaves. It doesn't enforce or do anything with those tasks. The real smarts, they come from the frameworks. Framework is a piece of software that contains one or two things. It has to contain a scheduler. Yes, it works. So it contains a scheduler, which, so as you can see, masters keep calling the framework, the scheduler, with the question, here's a list of offers, resource offers. Do you want to do anything with them? The scheduler says, yes, I want to do something. I'm creating a task. Or no, I refuse the offer. The executor is an optional piece. If you're writing a specialized framework and you have some common execution logic that you want to package into an executor, you could do that. So it installs on each of the slaves and executes them. One example, it's not real, but let's say you are designing a framework that runs Gradle builds. So running a Gradle build is a very specialized thing. So it would make sense to package the logic of how you run a Gradle build into an executor. So your tasks would say, executor Gradle builder, here's the build file. Go run it. But by itself, without anything specialized, Mesos slaves can execute shell commands. And since recently, they can execute Docker containers, which got my interest. This is when I started hearing Mesos and Docker in same sentence. So I prepared a demo. I've created a Java program, and I wanted to show how to deploy it on a Mesos cluster. So for each step, I tried to mark it with these two icons. They're kind of small, the Docker icon and the Mesos icon. So I'm indicating whether I use Docker or not and whether I use Mesos or not. Used green, didn't use red, could have used yellow. Notice that used but shouldn't have is missing because it pretty much applies to all steps. Because Docker has this really cool thing about it that this quote really applies. So if all you have is a hammer, everything looks like a nail thing. So I recently attended a conference on containers, Container Camp in San Francisco. There was one talk about one lady that works for Docker itself. She ran everything in containers. She ran browsers, Steam games in container, anything. Why? Because she can. No, I don't think she is. Pretty much because she can. It's really cool to run things in container. It is. OK, so I've created a distributed application. So finally, there is an application to calculate square roots. There is a server that holds work items, and there are clients that connect to the server. They check out a work item. They run the calculation to come up with a new approximation for the square root and submit it back to the server. The server checks the delta, and if it's close enough, it moves them into the good results category. Otherwise, it reinserts them into the work items list. I know it's not very real, but this pattern is pretty much real. If you look at things like, I don't know, folding at home, where people's computers are used to sequence genome, or Bitcoin mining, same type of thing. You have a server which holds work items, and you have clients that check out a piece of work, do something on it, submit it back. So it is a real pattern. So for the preparation of the demo, I have these few things running. So I have 3 EC2 instances. On each of them, I run Zookeeper, actually Zookeeper exhibitor. Each of them has Mesos master running. Each of them has Mesos slave running. So Mesos slave is the only thing that I couldn't figure out how to run inside a Docker container, because it needs to talk to the Docker daemon itself. I didn't want to mess with that. There is a special mode that you could, yeah.
Socket, one click Docker socket.
Right, I hate every word of this. I know you're right, and I've seen people do that. I just didn't want to do that, honestly. But pretty much everything else, I either did run in container or could have. I run my private Docker repository, just like it was discussed, and I run a Eureka server. If you attended the Spring Boot talk, which you really should have, you would know that Eureka is something like Zookeeper. Pretty much, it's a software that lets you register services and look up, discover services from it. So Spring Boot has really nice integration with Eureka. All the source code is available online. We could talk about this later. We just don't have too much time. Basically, it's a registry for services. So this is my setup. I have 3 machines. On each of them, I run Zookeeper, Mesos master, and slave, and Docker. And in one of them, which I have Elastic IP assigned to, I run registry and the Eureka server, because some things need to be known in advance. So the server is, of course, a Spring Boot application. It registers itself with Eureka, exposes web UI, and these are the only 3 pieces that I had to add to it to actually work with Eureka, which is kind of cool. You add the Spring Cloud Starter Eureka client probably. You enable Eureka client annotation, and you set your application name. Honestly, that is it. That's all you have to have this application go to the, well, you probably need the address for the Eureka server itself. Yeah, I do. Sorry. It's missing from the slide, but you need to have the address for the Eureka server. So it's a service, so it's a typical long-running task. You can make the connection, long run, marathon. Marathon is a framework that's designed to handle long-running tasks on Mesos. If you look at your data center as an operating system, that would be your Upstart or Systemd or similar type of software. It's also, when you really think about this, it's a very simple PaaS, platform as a service. So it runs your stuff. It can scale your task, do a lot of things that traditional PaaS systems would do for you. It, as with all these things, it exposes UI that's barely workable, but it doesn't cover a lot of the functionality, and REST API that you could do pretty much anything with. So it is deployed on a demo cluster. The way I deploy my server, of course, it's a Spring Boot application wrapped in a Docker container. So this is the image name for my container, for my Docker image. And this is the JSON I send to Marathon Framework. So name of the application. It will take 1 CPU. I just need 1 instance of it. It will take 1 gig of memory. And it's not a shell task, it's a container task. So use this, this image. Here's the interesting thing. Each Mesos slave exposes a lot of metadata about itself. It exposes the host name. It exposes types of, well, it exposes the resources that it manages. But you can also expose a lot of other things like tags, for example. Or you can add your own types of resources that it would manage for you. So in this case, I'm using the host name to actually say, yeah, you deployed in the cluster, but please only on the slave that, that is registered under this name. I didn't have to do this. Since it would register itself with Eureka, it could be running anywhere, but it was just easier for me to go to that URL because I know it up front. But I really didn't have to do that. So if we go to, OK, where is my mouse? I have no idea. Anyway. All right. So, OK, we have a Marathon UI. We have a server app running. If we look at Eureka, we see that the SQRT server is registered with it. And you see the UI for the application. So you have your work items. You have the results that's been previously calculated. OK. I ran it before that. It would take some time, especially to register with Eureka. There are about 1 million blog posts about why it's so slow to register with Eureka, the Spring Boot applications. So now I need somehow to run my clients. Client is a Spring Boot application wrapped in a Docker container again. Same type of thing. So it connects to the Eureka server. It finds out where the server, this square root server, is installed. It connects, checks out some data, does the calculation, and exits. So this is how it locates. Again, the source code is available online. I don't want to go too deep into that. But again, it's just stupid simple to do that, thanks to Spring Boot. Let's try deploying the client also on Marathon. I should have my REST client somewhere here. Deploy client. OK, so if we go to Marathon, we can see that there is now a client running. And if we go to the app, that we can see things happening. We can see things happening. You just saw things happen. Yeah, you see it again. So that Docker container gets started. It connects. It does all the things that I've described. It does the calculation. So it keeps doing that until it actually produces something that's good enough for the server. Couple more tries. So notice that green thing, good call, appearing at the bottom. That means that there was a piece of work to do. So everything's good. But now, the thing is, you see the bad call starts appearing. So Marathon handles your long-running tasks. So when my client exits, it says, oh, wait, I always have to have at least one instance of it running. So it starts it again and again and again. This is really not something that we want because it keeps hitting the server, which is wrong. And I want now to undeploy it. All right. Yeah, this is all live. So we've undeployed it. Now we get back to the client. Before we figure out how to run the client correctly, we need some input. We need some data to work with, some numbers. So we could emulate that with a call, with a scheduled call that will generate just random numbers for us. And again, remember the data center as the operating system. You have your replacement for cron, which is called Chronos. It was built by Airbnb. It's another framework that talks to Mesos and schedules stuff, schedules execution for you. Also, the UI is beautiful, very weird, not very functional. REST API is good. I recently had some problems with the API, so I'm gonna do something real quick here that will, if you excuse me, I will actually this time use the UI. So I need to add a new job. It won't be very. Let me pull this thing for 1 second. Okay. Sorry about this. Okay. Okay. All right, so I've created a new job that will keep hitting that URL with curl. It's a shell task. It will run indefinitely, start right now, and repeat every 60 seconds. And let's create it. All right. Let's see it actually. OK, so it already ran a couple times. If we go to our app, it keeps creating every so often, it keeps creating new work items for us. Good. That's what we needed. OK. Now, we need to do some smart scheduling of the client. We've seen that Marathon is not fit to do what we want. Chronos will do pretty much the same, but you can set how often it will do that. So it will still keep repeating running the client. So what's there to do? Anybody? Let's build our own Mesos framework. All right, it turns out to be a very, very simple task. There is an SDK available in all sorts of languages. I use the Java SDK. You have to when you run it, you have to have a native library installed because all the communication for all the Mesos frameworks happens through native library. Don't ask me why, it just happens. So all you need to do to implement a custom scheduler, you need to implement reactions to connect, disconnect events, to offers being presented, and task status updated. And you need to tell it where the Zookeeper cluster is. It will go to Zookeeper, and it will find your Mesos master processes from there. So at the very minimum, all you have to do is just implement the resource offers method. I know it's a lot of code, but if you used protobuf, you would recognize that. It's all that CRUD to just build simple data objects. First, you say that it is a container type of task. You give it the image ID, image name, and type Docker. And then you say that it will take this much CPU, it will take this much memory, it will use that container task, and launch task. That's really it. So, but before doing that, it will make, I have this method which will make a REST call to my server and ask, do you have anything for me to do? If yes, it will do all that. If no, then we decline the offer. And that piece of resources is getting offered to a next framework. So all those frameworks can happily coexist in one cluster. You can even run other frameworks inside Marathon because it's just another app. And we deploy that. Of course, I wrote it as a Spring Boot application. You know, it will also find out where the SQRT server lives through Eureka, do all those things. Let's deploy it. And we do that by using Marathon API again. And let's deploy Mesos framework. So it is another Spring Boot application wrapped in a Docker container. All I want to do is run it somewhere on my cluster. I really don't care where. OK, so my framework doesn't have any UI. Let's see if it actually works now. First of all, we could look at Mesos and see frameworks running. And now, yes, it's right here. SQRT framework, it appeared, so it starts, it was launched, it starts to work. So yeah, if you see here, you could see that calls are being made and everything works as expected. It's just, unfortunately, we've created too many inputs for it, so it will take a while to go through all those things. Let me cancel this thing. So it will take a while, but you know, if you sit long enough, you see that all those things will be actually calculated, and it will not make any more calls. So it will actually respect the whatever server tells it, whether it has work or not. That is really it. That is really the demo that I prepared today. In conclusion, Mesos is really nice. It's a valid candidate for managing your cluster. It's a very interesting way to deploy your applications. It allows you to implement really complex and smart patterns for deployment and for deploying and running your application. It is extensible. It's really easy to extend. And it really handles the scheduling and execution concern really well. It doesn't try to do anything else, just that, but in my mind, it does it really well. There are a lot of frameworks that work with Mesos, that were written for Mesos or have plugins for that. Hadoop, Spark, Elasticsearch, all those things, they would happily deploy themselves, run their stuff on Mesos clusters. Jenkins has a plugin. Well, Jenkins has a plugin for everything in the world. But they have a really smart plugin that acts as a Mesos framework. It would create, inside your cluster, it would create slaves on demand, run necessary builds, kill them, then create new ones. So it will take advantage of Mesos resources. Cassandra, Chris was talking about that very complex thing, that how it clusters. It knows how to tell Mesos to do that. And there are many other things. This technology is used by many, many companies. Containers are really everywhere. I ran everything, including this very presentation, out of a container, just because. Just because. The only thing that didn't run as Docker containers were Docker itself, Mesos master. It works just fine from inside container, but the image that I used already had it pre-installed, so I thought, you know, I didn't need to. And Mesos slave was really hard to get inside a container. Spring Boot, you must use it. Please look up Josh Long's presentation about Bootiful something. Bootiful. I think we did. Oh, yeah, that would be cool. Yeah, we could do that. So really, I haven't written Spring application in a while. So for me, wouldn't it be cool to have something like that done? Here's really the time it took me to get the database running was really 1 minute. REST API, service discovery with Eureka took me about 20 minutes to actually read the blog post and to put the code in. I'm actually using WebSockets. WebSockets are really cool. So those things that you saw, the live updates, this is WebSockets. Let's keep running, keep sending. So again, with Spring Boot, it took me about 40 minutes, including writing the JavaScript to handle it on the client side. Same thing with others. So you must use Spring Boot if you write Java applications. That's it. Questions?
Can you talk about the sort of intersection and the union of Mesos and Cloud Foundry? Or am I just totally...
No, I don't know anything about that.
How they intersect and how you put them together, and whether it makes sense to put them together, It just totally, in my mind, it's confused right now.
I honestly cannot answer that, sorry. I don't know how to run them together and whether it makes sense to run this together. The examples that I saw were data centers with fixed resources just combined into one big pool that's consumable by any type of load. I guess you could do dynamic clusters, so the masters and slaves could join and leave the cluster easily online. That's no problem. So you could grow and shrink your data center. Oh, one more thing. Mesosphere, the company behind Mesos, is preparing a new product called DCOS, Data Center Operating System. I didn't get the invite to the private beta, so they are soon supposed to go into public beta. I think what they will do, they will combine all these things and more into just one API, one CLI, one thing that will help you run this type of things. You should keep an eye on that. It would be a really cool offering.
Have you even tried to use Docker Swarm?
I tried, but I don't remember the result. I know that I tried, I installed it, I tried to deploy over, but I think that I still had problems. You know, there's great things about Docker Compose. Running them on different machines completely kills the whole idea. Just
you cannot run Compose on different machines.
Right. 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 So they're doing Weave now. That container camp that I've attended, pretty much every talk was about Weave or similar technology when they will somehow tie all those containers that you run on different hosts. They will tie into one network or one DNS. So it's basically an IPAM solution for Docker, which I think would solve a lot of problems that people are having. So this is the biggest problem in front of the Docker community. They do promise to solve it. They know it's a problem, so it's coming up.
Were you guys talking about this thing called Kubernetes from Google? Is that similar to Mesos?
No, it's Kubernetes can also run your Docker containers, but Kubernetes is a hosted solution. It is similar to EC2 container service. So basically, you run some VMs in your Google, whatever they call it, the app, and not app. You can install it locally as well, but it will manage several hosts for you. You install Docker on it. It will tell it to run Docker containers. So it's not Mesos. It's very different, but it is for containers.
Suffer the same problem as Docker Swarm. Explicitly in documentation, if you want to kill your cluster,
Right.
don't tell containers to talk with each other.
Right. Right. So I've tried Kubernetes. Basically, you write in JSON. You write a lot of service descriptors. So you can have a service that can have multiple instances. It will Google Kubernetes will keep an IP address for it. So those instances could be the containers that actually execute the service. They could be ephemeral, but that definition stays. You can join more instances. You can scale or shrink it as you wish. So you define all those things, and then you assemble it all into running multi-services cluster thing. So you could implement your microservices using that way. It will work just beautifully. This is just a different solution.
Like Mesos is this low-level thing, right?
Lower level, yes.
Custom management
Right.
sort of scheduling thing, and then Kubernetes is also cluster management but for Docker, but then it has service discovery built into it as well, and some sort of higher level things. And I guess, I mean, I haven't looked at Swarm in detail, but all these things are trying to attack a similar problem.
Right. So
It even, I mean, it's funny, I haven't looked at Cloud Foundry in a while, but even I remember an older version of Cloud Foundry. I mean, that had this sort of kind of master-slave, I need resources to run this service, find me a machine that has the available resources to run it, and tell that machine to go run it, right? This, all similar kinds of, clustering solutions.
right. So yeah, and Kubernetes is more like your PaaS solution. It's a different PaaS solution, but that's what it is. So you define your applications, you define your services, and links between them, and it will run it for you. Yeah, this is more, like I said, this is really concentrate on one thing, just executing tasks. And you can build all sorts of levels on top of it.
Thanks.
All right. That's really it. The source code for the presentation is available on GitHub. There are things, with Spring Boot that might be interesting. Please take a look.